Okay, so if this is my figure, name this figure. What is this? It's a triangular prism, right? So if I go vertically through this triangular prism, what is your cross section? A rectangle, right? Think of it as I cut right here, I opened it up, and I showed you a shape. It would be a rectangle. What if I went horizontally through this? A triangle, okay? Quick question, because some of you did it wrong just because of the wording. What is vertical? Up and down, right? Think of, like, I don't know, do you guys do the, well, none of you, very few of you end up taking PE anymore these days, right? When I was in PE was like one of my favorite classes. My like emphasis for my credential was PE. But when I was in PE, we had to do all these tests. Do you have what was it called? I don't know. You had to do like your vertical leap, the sit and reach. You had to do how long you could do the flex arm hang. I won that one. That was the best. Yes, I was pretty proud of myself. Still am, apparently.
Is that
Is what? Oh, I handed them out. You weren't here. Here. Yeah, so anyway, we had to do all these tests, and you had to test your vertical leap, right? So think about my vertical leap is how high can I put a little chalk mark on a wall jumping up? That's vertical. We want to go up and down. Horizontal, you think horizon. If you look out on the horizon, where does the water meet the land, right? Or what is the water line if you're looking way out at the ocean? So horizon, horizontal, vertical, this way. Don't mix those up because that's just unnecessary. So cross sections, if I go horizontally through this, what do I get? A circle. If I go vertically, a triangle. What if I go vertical through this? It's a square pyramid. Vertical through this. A triangle. Horizontal, a square, right? What if I go vertically through a cylinder? A rectangle. If I go horizontal through this cylinder, a circle. Okay, so cross sections. Good on those? Okay. And then we also drew them. I will draw one for you real quick. Okay, so if I gave you a cube and I said we want to go horizontally through the top and front. Okay, do you remember what you had to do with that? You need what kind of lines? Parallel, okay? So if I'm going to go through the top and the front, there is not one right answer. There are a lot of different right answers, but you have to make sure you go horizontally through both. So if I go a horizontal line through the front, a horizontal line through the top, then you just connect those endpoints. So here and here, and then we shade. Okay? Horizontally through the top and the front. Questions on any of those? Okay, so we're going to start on the back side of your worksheet, which is now crooked. Bummer. Sorry, we're going to write a little crooked here. So starting with number 5, you're going to find the surface area and the volume of a sphere. And you will have the sheet in front of you that says surface area of a sphere is 4 pi r squared. And volume of a sphere is 4/3 pi r cubed. And let me just warn you, because I saw this on the quiz, I don't want to see it again on the test. The formula is in front of you, right? You know it's 4 pi r squared. You know it's 4/3 pi r cubed. But so many people make them both squared, or they cube the surface area. Just follow the formula, okay? It is there for you. That's a simple mistake that just shouldn't be made. So just follow those formulas. You'll be good, okay? This is really just a matter of can you plug it in correctly. So if we're looking for surface area and volume, we're looking for a radius to plug in. What is our radius? 14. So you're going to plug in for r of 14. So it's going to be that doesn't look like a 14. 4 times pi times 14 squared, okay? Don't plug in the pi, just plug in 4 times 14 squared, and you get 784. And then your units are meters, and you square it. Okay? For volume, yes, sorry. That's the other thing that a lot of people are going to do wrong. See, I was just testing you. I totally knew what I was doing there. For volume, 4/3 pi r cubed. You're going to take 4/3 times pi times 14 cubed. So 4 divided by 3 times 14 cubed is a really ugly number, but that's okay. So 3,658. What's 0.6 repeating? 2/3. So, and 2/3 times pi meters cubed. That's a 6. Let's see if we can narrow this down a little bit. I don't know why it won't let me choose a different size these days. There we go. You what? I don't think so. I think we gave you nice numbers all the way through, unless you had to round. So that's volume of a sphere. Questions? All right, next one. A sphere has a surface area of 1,296 pi square feet. Find its volume in terms of pi. What do you do? You have a surface area, you want a volume. What's your unknown in both those formulas? It's a sphere. What's your variable in both of these? It's r, right? So you have r in common, so you need to find r to be able to plug it into the volume formula, okay? So we know this is the volume, or is the surface area. You need to find the volume from that. So you're gonna take 1296 pi, because that's our surface area, and set it equal to what? What is surface area? 4 pi r squared. So 4 times pi times the radius squared. Okay? All right, so we're here. What do I do to solve for r squared? For r, really, but eventually r squared. Or r squared, but eventually r. Divide by 4 pi. Now here's the beauty. If we divide by 4 pi, those cancel. If we divide by 4 pi here, what's pi divided by pi? It's 1, right? So the pi over pi is 1. So you can get rid of the pi's there. And then 1296 divided by 4 is 324. Okay, so that's your r squared. So what is your radius? 18. You're going to take the square root of both of those, and you get a radius of 18. Okay, what's next? Then you plug it into the volume formula. So we're going to take that 18 and say volume equals 4/3 times pi times 18 what? Cubed. Okay, make sure you cube that one. So 4 divided by 3 times 18 to the third comes out to this number, 7,776. Don't forget to attach your pi, like I did. And then it's feet cubed because it's a volume. Okay, so kind of working backwards to be able to go forward with volume. Questions on that? All right. This one, it says the surface areas of two similar figures are given. The volume of the larger figure is given. Find the volume of the smaller. What do we do? This is the one that I feel like is going to give people the most trouble on the test. Do you remember what you have to do with it? Right. Okay, so 240 over 1,500 is our surface area ratio, right? What's the first thing you should do with that? Reduce it, okay? Which is what? Well, right off the bat, you could divide by 10. What?
24 over 155.
4 over 25? Yeah. Do you know how to do that on your calculator? How do you do it? And then you kick the fraction to decimal, right? So if you just divide the number, and then there's a button on your calculator. Oh, you have a different calculator, so it might take a little time to find yours. But for those of you that have like Aaron's calculator here, you do the numbers divided by each other, and then let's see, hit the second key, and then when it PRV, second PRV has that F to D, takes a fraction to a decimal or a decimal to a fraction. Do you all see that? It's very helpful. So you would go like that, and then you go second that. Okay. So you can always do the divisions and get there, but this is a lot nicer. Okay, so this works out when you reduce it to 4 over 25. Right now, that is which ratio? Surface area. Okay, so we have an area ratio. We're trying to get to a volume ratio. So like Angelina said, we got to square root this. So you're going to square root both. The square root of 4 is what? 2. The square root of 25 is 5. Okay, so right now this is a scale factor. But we don't want a scale factor. We want what? We want volume. So we're going to take that number and we're going to cube it. So 2 cubed is 8. 5 cubed is 125. Okay, so this is scale factor, surface area, scale factor, volume. So we are at a volume ratio now. We know the volume of the larger figure. So if we set it up as a proportion, 8 over 125 equals something over something, where is that 1,562.5 going to go? Top or bottom? On the bottom, because it's the bigger one, right? We want it across from the bigger number. So we're going to put, I lost my number here, 1,562.5 on the bottom and X on top. Then what do? Cross multiply. So 8 times 1,562.5 and then divide by 125. So you get 100. 100 what? Meters cubed, right? 100 cubic meters because we're talking volume. So that problem's tough because it has a lot of steps to it. And if you miss a step, you get strange answers. Just make sure that you don't stop at the scale factor, right? It's easy to square root them and forget to cube it after that. So make sure you square root and then cube, or there were the ones that went from volume to surface area, then you cube root and square, okay? Yeah, Kenny.
So does it matter if the small numbers are top or bottom?
No, it doesn't matter. Like if your ratio has the bigger number on top, then you want your bigger volume on top, right? It doesn't matter, like, it just matters you keep them corresponding to each other. So small on top means small on top, large on top means large on top, okay? All right, number 8. If we're gonna find the volume of a composite space figure, what are we actually finding the volume of here? Two different things. Half a cylinder and a rectangular prism, okay? So let's just start with the volume of the prism because I feel like that's the one that is easier for people. Volume of a prism is the area of the base times the height, or since it's a prism, length times width times height is fine, okay? And this one, you can use anything as your base. You could use the square as your base, or you can use the rectangle on bottom as your base. What's your preference? What do you see as the base right now? Square or the rectangle? The rectangle? Okay, so if this is my base, then the area of the base is 6 times 15. Okay, what's the height then? 6, this other 6. So 6 times 15 times 6 is 540. Okay, so that's the volume of the prism. Then we have to do the volume of half a cylinder. What's the formula for the volume of half a cylinder? What's the formula for a cylinder? BH, okay? So if we're doing half a cylinder, we're going to do 1/2 BH, okay? What is B right now as a formula? Pi r squared, right? So this is pi r squared. What is r? 3. If this is 6, then our radius is half of that, making it 3. Okay, so you're going to do 1/2 times pi times 3 squared. What's h? It's 15. It's the height of the cylinder, so it's the distance between the two circles there, which would be this. This is the h of your cylinder. So that's 15. And then you're going to plug that in. So 1/2 times 9 times 15 is 67.5 pi. That's a pi, sorry. So that's the volume of the cylinder. Okay, we want the volume of the whole thing. So you're going to take 540 plus 67.5 pi. As an exact answer, that would be it, meters cubed, but that's an ugly exact answer. So we'll just say round to the nearest tenth. So if you plug that in, 540 plus 67.5 pi, you would get the volume is approximately 752. We'll just leave it to the nearest whole number for this one, cubic meters. Okay, and just pay attention to where you're asked to round on those. Any questions on that?
Is this the same format as it will be on the test?
What do you mean, the worksheet?
Section, yeah.
Um,
Similar problems and then
yeah,
change the numbers.
similar, like shapes can change, right? But for sure, like the 1 through 5, it's like, here's one of these, find the 3. Here's one of these, find the 3. Here's one of these, find the 3. So you'll have majority of that exactly as you see it with different numbers. But then the other stuff, you know, I'm not gonna, like number 6, it's not necessarily a sphere that I give you the lateral area and you have to find the volume of. It could be a different shape, or number 7, I could go volume to surface area instead of surface area to volume, that type of thing. Number 8 could be 2 different figures that we're putting together to find the volume. But same ideas, right? Same basic ideas. Any questions on any of those? Okay, how about just in general? Front side, back side, review assignment. Is there anything you want to see more of right now? Because we have a few minutes still.